So, Praveen Kumar. Praveen Kumar.
Hello, ma'am.
Yes.
Hello, ma'am. I'm audible.
Yes, Praveen, you are audible. Is this your first class?
Yes, मैम हमारे शेड्यूल में GIS का कोई लेक्चर ही नहीं दिखता है।
आप क्या नए ज्वाइनी हैं?
नहीं मैम, हम ज्वाइन 6 को किए हैं, 6 सितंबर को ही।
6 सितंबर को आपने ज्वाइन किया है। ओके, सो
हाँ, 6
आपके
सितंबर
पास
को ज्वाइन।
तो GIS की क्लासेस
कैलेंडर
कर रहे थे?
नो मैम, कोई कैलेंडर ही नहीं शो करता GIS का।
तो आपको
कैलेंडर
पहले
पे कोई मीटिंग
आपको कम्युनिकेट करना चाहिए था ना ये चीज। आप
मैम हमें पता ही नहीं चल रहा था। कल का नाम राहुल कुमार से पता चला एक GIS के लेक्चर होते हैं।
टाइम टेबल आप लोग के पास नहीं है क्या?
मैम जो क्या नाम माइक्रोसॉफ्ट टीम में प्रोवाइड किया गया वो हमारे कैलेंडर में GIS का लेक्चर अब नहीं है।
क्वेश्चन सुनिए प्रवीण, आपके पास क्या टाइम टेबल की कॉपी नहीं है?
नो मैम।
ओके, आप ऐसा करिए, आप मेरे मेल आईडी पर या यहीं पर अपना जो MS टीम का आईडी है आपका वो मेरे को मैसेज करिए, ठीक है?
ओके मैम।
आप उसको मैसेज करिए, शायद आप टीम में एडेड नहीं है इस कारण से आपका नहीं आता है।
Ma'am, can you please repeat the first question, ma'am?
Sorry?
Ma'am, can you please repeat the first question?
Give the name of 6 parameters that are used to define the Earth, mathematical model of the Earth. Okay, so the answer is semi-major axis, semi-minor axis, flattening, inverse flattening, eccentricity, and second eccentricity. These are the 6 parameters that are used to define the Earth. Next question is, you have a longitude value of 81 degree, write it down, 81 degree, sorry, 81 degree, 50 minute, 30 second west. Just writing it down.
Ma'am, that's 5050.
I'm just writing it down. 81 degree, 81 degree, 50 minutes, 30 second west. Okay. So this is the longitude value. Convert it into the decimal degree notation. Quickly convert this value into from
Ma'am,
DMS to DD. Yes.
82.33333.
80. Repeat.
Point
82.3.
3 repetitive, ma'am. 3.
Is it correct?
3. Yes, ma'am.
It will be 82 or 81.
81 plus
81.8416.
Yes, ma'am, same.
Is this okay? 81 point all cheese?
82 point,
No,
ma'am.
81.25, 83.
How it can be 82?
Ma'am, 81 plus 50 divided by 60 will get the value 0.8333. And the 30
Ma'am,
divided
81.8416666666. No,
Ma'am, this is one is right.
81.2583.
Yeah.
Ma'am, 81.84166666.
There are so many values. I am just calculating it.
Ma'am, I got 81.841.
Just wait for a minute. I am just calculating it. The answer is this.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So you cannot get 82. Okay. If you are getting 82, you have done some mistake. The answer will be like this. Okay. So this is the correct answer. Is there anything else that you need to add in this one? Anyone?
East, ma'am.
Just quickly try. Yes.
East. Sorry, west.
West, degree and west.
So when we use to store it inside the computer, it will be in negative value. Okay. So west will not be written like a west over here. It will be stored as a negative value if we are storing it inside the computer. Okay. So it will be minus 81.84 degree because it is in west direction. If it is the east, then it will be in the positive value. Okay. Now do the reverse conversion. Quickly convert this 81.8416 into the DMS notation. This one is the decimal degree notation. Convert this decimal degree notation into the degree minute second notation.
Ma'am, 81 degree, 50 minutes, 49.960 seconds.
Okay. So everybody has got the answer?
Yes, ma'am.
Okay then. So now after doing a revision of the previous lecture, I am moving to the next one. And now in today's turn, we are going to start the spatial data. First question is, what is spatial? Whenever we store a data, we will discuss in more detail later on, but whenever we store any data, straight. As you can see on the screen, there are some points over here. Is it visible?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
This data is the spatial data, because it is giving you a location. If you put your cursor on any of the point, and at this bottom right end corner, you will find the lat long value. In this case, it is a projected data, so you are getting XY coordinate. Okay. This one is an UTM coordinate system. So whenever I am putting my cursor on any of the point, the XY value is coming at the bottom. So these points are the spatial data. Okay. Now if I check the information of any of the point and click on that point, you can find that some of the information is given over here. Feature ID is 199, shape is point, object ID is 200, ID is this, name is some North Avenue, some street is given, and other information is carried over here. So all this information is the example of attribute data. Whenever we talk about the GIS data or the spatial data, it always have two components. First is the spatial component, and second thing is the attribute component. I have opened another data. This one is the New York City Census Block. Okay. So again on the screen you can see that there are so many blocks that are created over here like this. Okay. And if I place my cursor and click on any of this, you can find the detail. The whole detail is coming over here. Like this. Okay. So the FID is given, shape is Polygon, block ID is given, total population is of 151, white population is 1, black population is 145, natives 0, Asian 0, others 0, total number of household 47, owned household 14, rented household 33, borough name Brooklyn, area this much, population density is this much. Okay. So this is what, this is all about the attribute of that particular location. So right now on the screen, the boxes that you are seeing, they are the spatial data. Okay, they are the location data, and with every location there will be some information. Like suppose if I say MNIT, okay, and suppose its coordinate is simply 8125, 81 degree east, 25 degree north. Okay, suppose. So this is what, this is the location of MNIT, and this one will be the spatial data. 81 degree east, 25 degree north is the spatial information. But if I associate some other information with this particular coordinate, that institute name is MNIT, total number of students 8,000, total number of faculty 250, total number of staff 500, so on. So all this information will be the attribute information. In GIS, whenever we build any data, it will have two parts in this way, a spatial component part and the attribute component part. Okay. So this is what the spatial data is. Write down this term in your copy, spatial data. As I have told you earlier, remember the spelling of this term. Many times you write special, S-P-E-C-I-A-L. That is something else. This is else. This is a spatial. Okay. This is not spatial. This is not spatial. This is a spatial. And the spelling of spatial is S-P-A-T-I-A-L. Okay. If we see first of all about the sources of spatial data, there can be a primary data and there can be a secondary data. Primary data means if I'm collecting any of the data by myself, it is a first-hand observation for a particular project. Like suppose if I want to study on a particular field and I want to, I want to gather the information of all the schools. Okay? So I will take the GPS receiver, go into the field and just collect I will visit every school and collect the location of every school. This will be the primary data. Similarly, if somebody want to study about, suppose there is any disaster at some place and the government is doing aerial mapping of that region. Okay. Again, the data that will be collected for that one will be the primary data because the data is collected specifically for that purpose. Second category is secondary data. Like suppose if there is any satellite data, Landsat data. Landsat data is a data which is not collected for any specific purpose for you only. Okay? It is a data collected by the USGS and then you can download that data and use for your own purpose. So such type of data is a secondary data. You are taking the map data. Okay? All of you have the topographic sheets of Allahabad and that data is not collected for you or for your project. Okay, it is just published by the government of India. You can take that data, you can extract the administrative boundary of the district. So such type of data will be the example of secondary data. Whenever we use any data, whether it is a primary data or it is a secondary data, there are three modes over here: temporal data, thematic data, and spatial data. So when we say spatial, it will convey the information of the location. Okay. Next thing is thematic. Thematic means based on a particular theme. Okay. So what is the theme of that data? It shows the thematic component. Next one is the temporal. If there is a time associated with that, then in that case it is a temporal data. Especially when we work on the images, in that case the temporal data become important. The temporal component is always considered over there. Next, about the sources of spatial data, how we can get the spatial data. First and the most important source is the map. Okay, you have already started to work in the map. Okay, so whether it is a georeferencing or whether it is a digitization, everything that you are performing is on the basis of map. Second thing is the land surveying. This is a traditional way of collecting the data. Nowadays, we are using GPS to survey the thing. The next is census data or survey data. Government of India collect the census information in every decade. Okay? It is a decadal data. In this census data, there is a lot of demographic data associated with that, like number of people, number of male, number of people, number of literate male, number of literate female, illiterate male, illiterate female, then number of household, then there is this marginal workers, agriculture workers. So many categories are there in which the census data gives you information. Apart from the census, there are different type of surveys that are carried out by different government, by the state government as well as by the central government. Like you have heard that government is conducting health surveys, employment surveys. All these are the data. Now, these are not only the simple data, they help us to build the attribute information to associate it with the spatial data. I have just shown you the example of New York City. In that one, when I was clicking on different census blocks, you can see the information of total population, and then depending upon the race, like white people, black people, Asian, native, household, rented, owned, all this information is provided by that. So basically what has occurred, they have associated the spatial data with the census data. Then Aerial photographs and satellite images, these are the remote sensing data. And again, the remote sensing data is directly used in the GIS. So this is not an exhausted list of spatial data. There are so many other things that are coming day to day. Like nowadays we have the LiDAR data. So that one is coming. There are UAV surveys, unmanned air vehicles. So there are so many data that are coming nowadays. Remote, whatever you are producing with the remote sensing, many times it works as an input for the GIS. Okay, so these are the different sources. The remotes and the aerial photographs, satellite images, it will be covered in the different subjects. But if I go to the first one, map, this is very important data, and we will have a very detailed discussion on this map. Okay, and it is not just only in the theory, in the laboratory session also you are finding the use of map. All the initial practicals will be carried out on the map. Okay, whether it is georeferencing, digitization. In the next to next laboratory session, we will start the attribute analysis. Everywhere you will find the map as the source of information over there. Now I am coming to this map part. Okay. First, about the history of map. So map is nothing new. From a very long time, the map has been used. Okay. Even like suppose if you want to describe somebody the location of some place, okay, one thing is that you will tell that person your location in a verbal manner. Another thing is you can draw something on a paper, like go to this place, take a left turn, then go straight, you will find a crossing, take a left turn, something like that. So roughly you draw something on a paper so that another person can identify the location. So you are also creating a map. But if we go to the history again, we will find that there are, from a very long time, people are using the map. And whatever is the development in the field of ink, in the field of paper, in the field of publication, they have a direct impact on the map because everything is related to each other. Like when we talk about GIS, we say that whatever changes are taking place in the field of computer science, in the field of web, they have an impact on the GIS. Similarly, in the early time also, there is a direct impact of the paper, ink, and other things. So initially, people used to draw everything on a maybe on a clothes and other things. Over the time, people started to create a library, and inside the library, they put the maps. Okay. But the problem was there are several accidents which are like fire or flood that has resulted in the complete destroy of those libraries. Some of the popular libraries, Alexandria Library, and even nowadays we have a Alexandria Digital Library. They have converted that thing into the web. Okay. So some of the incidents are listed over here. Later on, with the printing press invention, okay, a lot of data started to get published and map become popular, because before that it was difficult to copy the map. A person has to draw that thing completely by hand. So the reproduction of the map was difficult before the invention of printing press, but after that it was so easy to create the map. Okay. Then there was an age of discovery where when in different countries or continents, people have started to navigate throughout the world, started to search different parts of the world, started to find out the path of different world countries. So this is called the age of discovery, and map has been one of the major source, and there is also a lot of improvement in the map at that time. Okay. So this is about the history. I'm quickly moving to the topic of map. So if you try to see what is map, okay, so the traditional method of storing, analyzing, and presenting spatial data is the map. Okay. Then map is of fundamental importance in GIS as a source of data, a structure for storing data, a device for analysis and display. Perhaps more important, maps have shaped the way most of us think about space in 2 dimensions. Therefore, understanding maps and how they are produced is an essential starting point for exploring the characteristics of spatial data. It is common to make a distinction between thematic and topographic maps. Okay? There are two, although there are several classifications in maps, but first the two major classification is given. First is the thematic map and second one is a topographic map. So if I take the first one, thematic map means, as the name suggests, a map which is based on a particular theme, okay, like road map. So it will be the thematic map because it is based on a particular theme of road. Soil map, sorry, soil map, rainfall map, temperature map, pressure map, land use, land cover map. All these are the example of thematic map. Okay. Second category is the topographic map. What is topographic map? It is a general purpose map. The map that you are using in the laboratory sessions is the topographic map. These topographic maps are the general purpose map and they carry all the information. One of the very important thing is that they carry the administrative boundary information. Topographic map are mostly produced by the government of that country. Thematic maps can be produced by anyone, but usually the topographic map is produced by the national mapping agencies. Like in India, it is Survey of India. In America, it is USGS, United States Geological Survey. Write down this name. I do not know how many people know about this one. Just write down this name, USGS, and write down the full form, United States Geological Survey. So next we are seeing the issues that are related to mapping process. One by one we will learn about all. I'm first reading it and then visit each and every one. Establish the purpose of the map. Next, define the scale at which map is to be produced. Select the features or spatial entities from the real world which must be portrayed on the map. Choose a method for the representation of these features. Generalize these features for the representation in 2 dimensions. Adopt a map projection for placing these features onto a flat piece of paper. Applying a spatial referencing system to locate these features related to each other. Annotate the map with keys, legends, and other text to facilitate the use of the map. So these are the issues in mapping process. First one is about the purpose of map. Whenever we make a map, we cannot put each and everything in the map. We have to select because it is not a real world content. We have to select something and then we can make a map. Okay. For example, this is 63G P15 map. As you can see on the screen that on this map, okay, this whole portion is completely, there is nothing in this portion. Okay. And if I open the image, this one is the sentinel image and its resolution is 10 meter. So you can see on this image that so many details are present on this thing. So when we say about the image, it is basically a snapshot of reality. Whatever is present on the ground, it is given over there. But when we talk about the map, in the map or while making a map, we have to select some of the things, otherwise it will not be possible to make a map. Now, what objects that we will select to make a map, it depends upon the purpose of the map. What is the purpose of that map? Okay. So whether the purpose is some propaganda, okay, like an example is given over here, like During the World War II, the countries want to say that they are at a better position. So that's why what they were doing, they were creating a map and showing that how much portion that they have captured. So this one is the propaganda map, and they want to show their citizen that they are at a better position. Okay, so it depends upon the purpose for which the maps have been created. If you remember, few months back there was a conflict between India and Nepal, and they were saying that this Kali Nadi is in our area, and this India is claiming that this one is in our area, and the Nepal was saying that no, this one is in our area. So for that purpose, what they have done, they have created a map and shown that conflict area inside their own country. So this was the map that was created to serve a specific purpose, to show that they have their authority on that land. Okay, so to show these type of thing, to claiming that no, this disputed land is under our control. People used to, or the government used to make such type of map. Another thing is, who is going to use our map? Okay, depending on that also, we are going to add the things. Okay. So it depends upon the purpose, it depends upon the users, viewers, who will, on the basis of which it will be decided what will be the content of the map. Next thing is the scale. This is very important. Okay. This is very important, and listen this thing very carefully, because sometimes it creates confusion. First thing, what is map? So as it is given over here, scale can be defined as the ratio of a distance on the map to the corresponding distance on the ground. This is the definition of scale. Write down in your copy. Scale can be defined as the ratio of distance on the map to the corresponding distance on the ground. There are three ways in which the scale can be represented. First one is the ratio scale, second one is a verbal scale, and third one is the graphical scale. Okay. So before going into that detail, first try to conceptualize what does it mean by scale. Whenever we are doing a mapping task, basically we are creating, or we are trying to portray the earth on a paper. While doing this thing, we have to decide how much content that we are going to place inside it. It depends upon the scale at which we are going to perform the mapping. Okay. When we have a map, okay, the scale is always associated with a map, not an image. Okay. With the image, there will be a resolution, there will be a spatial resolution. But when we talk about the map, we never use the term spatial resolution over there. We always have a scale with the map. Okay, remember this thing, that scale is associated with the map, spatial resolution is associated with the image. Okay. The map have a constant scale. Okay. Throughout a map, whichever portion you will visit, it will have a constant scale. So when we have a map, it will tell us that suppose a portion is drawn on a map, so it will be equivalent to how much area on the ground. Okay. Like suppose 1 is to say 1000. Okay. So 1 centimeter on a map is equivalent to 1000 centimeter, or 1 kilometer, you can say. 1 centimeter on the map is equivalent to 1 kilometer on the ground. How I can say such type of thing? Because the scale will be there, 1 is to 1000. Okay, so this is what the scale is. The scale can be given in three different ways. In the form of ratio. Ratio means 1 is to, like it is written over here, 1 is to 1 lakh. So you can, there is either a ratio or it can be a division symbol over there. 1 is to 1 lakh or 1 divided by 1 lakh. So in a representative factor, the number on the left hand side, this 1, okay, the value on the left hand side is the map distance, and the value on the right hand side is the number on the ground. The left hand side is always 1, okay, So 1 unit on the map. And then whatever is written on the right hand side, it will be the number on the ground distance. This is one of the very common way of representing the scale on a map. Another method is verbal scale. Okay. So verbal scale is, it will say something verbally as it is written in this table. 1 centimeter represents 50 meter. 1 centimeter represents 10 kilometer. So this is the verbal, or this one is the nominal scale. So whenever this is written thing, we do not refer to verbal scale much, but ratio scale, and second one is the third one is the graphical scale, which is quite commonly used. Now, this is the third one is the interesting. All of you have seen this type of graphical scale, isn't it? Does anybody know how to read this graphical scale? Anyone? How will you read this graphical scale, or how will you perform the conversion on the graphical scale? Yes?
Ma'am, on the map, when we see that kind of graphical scale, so ma'am, the length 0 to 100, it's mean on the map.
Your audio is not clear. Please place your microphone properly.
Now ma'am is clear?
Yes.
मैम अगर मैप पे ऐसा कुछ स्केल बना है तो जितना लेंथ दिख रहा है 0 से 100, तो मैम एग्जैक्ट उतना लेंथ मैप पे 100।
आपकी आवाज नहीं आ रही ठीक से। ये कॉमन प्रॉब्लम होता है स्टूडेंट के, आप लोग आगे भी ध्यान रखिएगा। कई बार वाइवा में भी ये प्रॉब्लम आती है, पता नहीं आपके उसमें एंड पे हो रहा है कि नहीं। कई बार स्टूडेंट क्या होता है, बोलते टाइम हिलते हैं, आगे पीछे आप मूव कर रहे हो, माइक्रोफोन एक जगह रहता है तो आवाज एक बार आती है फिर एक बार चली जाती है। हमेशा ध्यान रखिए बोलते टाइम, ये वाइवा में बहुत प्रॉब्लम होता है। माइक्रोफोन एक बार आप अपना चेक कर लीजिए क्योंकि आवाज बीच बीच में चली जा रही है आपकी। ओके, और कोई भी आंसर कर रहा है?
मैम स्केलिंग फैक्टर से या तो मल्टीप्लाई करेंगे एक्सपैंड करने के लिए, और नहीं तो डिवाइड करेंगे।
ग्राफिकल स्केल की बात हो रही है यहाँ पे, ठीक है। ग्राफिकल स्केल को आप कैसे रीड करेंगे?
Ma'am, in this like second one, 1 centimeter represent 10 kilometer. So ma'am, 1 centimeter on the map represent 10 kilometer on the ground.
I do not know what you are answering. I am asking about the graphical scale. This one is the graphical scale.
Ma'am, what we actually do is that we measure the distance which is given in map by some scale, and whatever is that distance, we measure it between that two cities or between 2 points, and we multiply it by that distance which is given in a scale form. Suppose there is 2 places, Allahabad and Kanpur. First we measure the scale which is given at the top right corner of the map, which is given that right side graphical one and right side. Then we measure it by some scale, by any plastic form or anything, and we measure the distance between that 2 cities on given on map, and we multiply that the distance which is given on scale 1.
लास्ट में आप थोड़ा मिस्टेक कर दे रहे हैं। ये सब लोग ध्यान से सुनिएगा क्योंकि ये बड़ा पूछा जाता है कई बार, और स्टूडेंट आंसर नहीं कर पाते कि ग्राफिकल स्केल को पढ़ा कैसे जाता है, बिकॉज फर्स्ट एंड सेकंड देयर इज नो प्रॉब्लम इन दैट वन। रेशियो स्केल क्लियरली आपने जो भी मेजर किया, लाइक सपोज you measure 2 centimeter on the map. Okay, so what you will do, 1:5000 is given. So if you are measuring 2 unit, say 2 centimeter on the map, so what you will do, 5000 multiplied by 2, so it will be 10,000 centimeter on the ground. So conversion, there is no problem. But when we come to the graphical scale, no such thing is mentioned over there. Okay, आपके सामने एक ड्राइंग बनी हुई है एक तरीके से कह दें, और उसको स्केल में के फॉर्म में दिखाया जा रहा है। ग्राफिकल स्केल का यूजुअली जब हम लोग यूज करते हैं, ये क्विक एस्टिमेशन के लिए यूज होता है। ठीक है, इसमें हम क्या करते हैं, आप चाहे एक स्केल ले लीजिए या किसी भी तरीके से इन्हीं 2 पॉइंट के बीच का डिस्टेंस आपने मेजर किया। ठीक है, आपने स्केल लिया और 2 पॉइंट के बीच का डिस्टेंस वहां पर नापा, और फिर उसी स्केल को ला करके इस ग्राफिकल बार के ऊपर रख दिया जाता है। ठीक है, उसको रखते ही आप एक एस्टिमेशन दे देते हैं कि अप्रोक्सीमेटली ये डिस्टेंस जो है वो 10 किलोमीटर का है या 20 किलोमीटर का है या 30 किलोमीटर का है। ओके, इस तरीके से ये ग्राफिकल स्केल को पढ़ा जाता है, जिसको हम एक बार फिर से आपको मैप पे दिखाएंगे तो और क्लियर होगा। बट ये 3 बेसिक मेथड हैं, रेशियो स्केल, वर्बल स्केल एंड ग्राफिकल स्केल ऑफ रिप्रेजेंटेशन। इसको आप थोड़ा मैप पर हम लोग देखते हैं। We are already working on P15, okay? So I am opening this map, G44 P15. Okay, let's check the scale of this map. So the scale of 63 GP15 is 1:50,000. Okay. Now suppose I have another map 63G. Okay. This map is at 1:250,000. Okay. Are you getting the question? You have seen one of the map G44 P15. The scale of this map is 1:50,000. Right now that map is open on the screen also. Now I have another map 63G. The scale of this map is 1:250,000. Write down in the copy. Just so I have G44 P15 and I have another map 63G. Okay. The scale of this map is 1:50,000. Scale of 63G is 1:250,000. This one is the scale. Okay. Now my question is whether the area covered by 63G will be more than P15 or it will be less.
More.
जी में एरिया ज्यादा कवर।
This is a statement correct?
Yes, ma'am.
Yes, ma'am.
Is there anybody who is saying that it will be reverse, area covered more in G44 P15?
Yes, ma'am.
Yes.
Ma'am, in the 63G on ground area will be more and on map area will be less.
So no, the question is suppose we have a sheet of A4 size paper, okay, and you have a map G44 P15 on the A4 sheet paper and 63G also on the A4 size paper. Now, which topo sheet will cover more area of the ground? Size is same, दोनों में A4 size ही ले रहे हैं. किसमें ज्यादा इलाहाबाद का एरिया कवर होगा और किसमें कम एरिया कवर होगा?
मैम 2.5 लाख में ज्यादा एरिया कवर होगा।
So the statement is correct.
Yes, ma'am.
Yes, ma'am.
So level of detail for both the cases, in which one the level of detail will be more or in which level of detail will be less?
मैम
First
50,000।
one level of detail is more, and second one level of detail is less.
More on P15.
One statement is more, which one is for less. Is it correct?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now, which one is the large Which one is a large scale map and which one will be a small scale map?
P15 is large
This is the
scale.
largest scale map.
P15 is large scale map.
15 is large.
Small scale. 63 is a small scale.
Is it correct? Okay, what you need to do, you need to write down all these things in your copy and let's check whether the statements are correct or not. Write down all these points in your copy and then we will check whether it is correct or not. So it's already 11:53. First, I'm giving you 10 minutes break, and then I will show you the comparison of both G44, P15, and 63G. Okay. Praveen? प्रवीण कुमार।
यस मैम।
आप प्रवीण आप लेबोरेटरी में भी नहीं आते हैं ना?
नो मैम, क्लास मतलब शेड्यूल कैलेंडर शेड्यूल में है ही नहीं।
आप लेबोरेटरी सेशन में भी नहीं ज्वाइन कर रहे हैं?
तो मैम अब कैलेंडर में शो नहीं करता तो मैम ज्वाइन नहीं कर पा रहे हैं।
आप कौन सी क्लास में जाते हैं?
रामजी द्विवेदी।
आप डॉक्टर राम जी की क्लास केवल कर रहे हैं?
यस मैम।
बाकी कोई भी सब्जेक्ट की आप क्लास नहीं अटेंड कर रहे हैं?
नहीं मैम, मनोहर यादव की डॉक्टर मनोहर यादव की क्लास भी बीच बीच में अटेंड कर लेते हैं जब कैलेंडर में शो कर देता है।
ठीक है प्रवीण, आप अपना वो भेजिए, MS Team ID भेजिए मुझे, उसको मैं देखती हूँ।
भेज दिए मैम, मैसेज कर दिए हैं।
चैट पर है? ओके। प्रवीण आपने कहाँ पर भेजा है अपना ID?
मैम मैसेज किए थे।
अरे किस पे मैसेज किया है?
एक मिनट मैम।
आपका तो कोई मैसेज है ही नहीं मेरे पास में, ना मेरे ईमेल ID पर है ना MS Team पर है।
मैम सर ने शेड्यूल भेजा था मैम सबके।
सॉरी अरुण, आपका ऑडियो मेरे पास नहीं आ रहा है ठीक से।
मैम ही सेइंग दैट कि रामजी सर ने सबको शेड्यूल मेल किया था, टाइम टेबल जो नया वाला आया है वो सबको मेल किया था।
एग्जैक्टली वही मुझे भी स्ट्रेंज लग रहा है कि मेल टाइम टेबल कैसे नहीं, क्योंकि वो टाइम टेबल टीम्स पर अपलोड होता ही होता है।
प्रवीण ने शायद लेट ज्वाइन किया है जिसकी वजह से उसकी आईडी सर के पास नहीं रही होगी, तो इसलिए उसको नहीं गया होगा सर शायद।
क्योंकि प्रवीण का किसी में भी नहीं आ रहा है, ये मैं देख रही हूँ कि उनका किसी में भी नहीं आ रहा है। एंड इट्स ओके। प्रवीण आप अपना चैट मतलब कहीं भेजिए, मेरे को कहीं आपका मिल नहीं रहा है।
मैम फीड में भेजा है इसमें।
सॉरी
मैम एक्टिविटी में, मतलब फीड में।
ओके प्रवीण, मेरे को मिल गया है, ठीक है। Let's start the class again. Okay. So we were discussing about this thing, the comparison between two sheets, okay, G44, P15 and 63G. Now you can see the changes over here. You are already known about G44, P15. Let's see this 63G map. Oh, the scale is visible, 1:2,50,000. Okay, so this is the scale of this map, and you can see the size of this map. Okay. This one is the portion which is covered by the 63G, and this small portion is covered by G44, P15. Okay, so the first thing is about the area covered. So this is clear that if we have a small scale map, okay, 1:2,50,000 is a small scale map. So for a small scale map, larger area is covered as compared to a large scale map. Okay. Now, why are we saying this one is a small scale map? Although the value of 2,50,000 is more than 50,000.
In a larger scale, less
Because
information
the
is there, and
details it contains is smaller.
Okay, please repeat.
Ma'am, the detail it contains is lesser than that another one map.
No. If the value is 2,50,000 and another value is 50,000, why we are saying 2,50,000 is a small and 50,000 is large, although the value says inversely?
Ma'am, that magnitude of that ratio is also smaller than that 1/50,000.
Yes. So if you see the scale, it is basically division by 1 divided by 2,50,000, 1 divided by 50,000. Okay. So if you have a ratio value, if you divide 1 by 2,50,000, it will give you smaller value as compared to 1:50,000. Many times there is a confusion among the student that that the value is more, 2,50,000 is more. Why we are not saying it a large scale map? So remember this thing, that this is not a value, this is the ratio, 1 divided by 2,50,000. 1:50,000. So this one is the ratio. So automatically you should remember this thing, that 1:2,50,000 will be a small scale map and 1:50,000 is a large scale map. Now coming to the next point about the area covered, it is open on your screen. The area covered by small scale map is more. Okay, a very large area of Allahabad is covered on this map, and if we compare it, this G44 P15 map, smaller area is covered. Okay. Now let's see about the level of detail. So this one is the urban area or urban settlement of Allahabad. Okay. At G44 P15, at large scale map, you can see so many detail in this urban settlement area. Now if I uncheck this one, okay, you can find the detail on small scale map. It is much less detailed if you compare it with this large scale map. Okay, so level of detail is different. Although the map is quite old, we cannot exactly compare the urbanization with that one, because this small scale map is surveyed in the year 1972-73. So this is a very old map, but you can find the details are much less in large scale, in a small scale map as compared to a large scale map. Okay, I hope these things are clear to you now, how small scale map will appear and how a large scale map will appear. Now, why the both maps are overlapping? Because of which? Yeah, correct. Both maps are georeferenced So they are representing, like this portion is represented, this lat long area is represented by both the map 63G and P15. Both the maps are representing this area, that's why they are exactly overlapping. So this is why we used to do the georeferencing. Okay, so the thing will get associated with a particular place. Okay, now coming to the next part, that is about the scale. On this map, you can find that the scale is 1:50,000. This one is the ratio scale. Then 500 meter to 1 centimeter, 2 centimeter to 1 kilometer. All these things are the verbal thing. Now I am coming to this part which we have earlier discussing about this graphical scale. Okay. On the screen you can find this bar, and the values are 0, 1, 2, 3 kilometers and 0, 500, 1000 meter. Okay, so this is 0, 1 kilometer, 2 kilometer, 3 kilometer if you move towards the right hand side of the 0, and if you move towards the left hand side of the 0, smaller marking are taken place, half kilometer, 1 kilometer, 500 meter and 1000 meter. Now how I will read this scale? Okay. So as I have told you that these are quite useful when we are estimating any distance. How it is used? Just wait. Okay. Now suppose I have drawn one line like this. Like this. Right on the screen you can find that I have drawn one of the line over here, and now I want to find out what will be the area or what will be the length on the ground. Okay, how you can do this thing? A very quick way of doing this thing is, if I place this line, okay, if I place this measurement on this particular bar, okay, now you can see, okay, so it is approximately, you can say, it is 1 kilometer, 5, 6, 7. So 1.7 kilometer. This is the rough estimation of this line, isn't it? This is the rough estimation of this line. Are you getting how I am using the graphical scale? I am placing, suppose in this one, because it is not possible to show you the scale and other things. But as you can see that I have taken one of the line, okay. Suppose this is the line between, there are 2 points over here, okay? Like the distance of this particular circle from this road. So what I will do, I will take a scale, okay. So I will take a scale, I will measure this distance from this particular circle to this road, okay. Then later on, I will take up this scale and place it on this graphical scale. This will give me a rough estimation that the distance will be approximately 2.25 kilometer. Is it clear now how to read a graphical scale? If anybody have any confusion, please come forward and ask the question, because this is important. Scale, whole map thing is important, and these are the very basic thing. So many times during the Viva session, students are not able to answer this question that how to read this graphical scale. So you are going to create all the map and all these scales in the laboratory session, and you are going to use these things. So this thing must be very much clear to you how to use the graphical scale. Is there any confusion? कोई ऐसा स्टूडेंट है जिसको अभी भी नहीं समझ में आ रहा है कैसे करना है इसको?
मैम एक बार और रिपीट कर दीजिए।
ओके, इसमें क्या करना है, अगर आपको मैप पर किन्हीं दो पॉइंट्स के बीच में आपको देखना है कि इसका ग्राउंड में इक्विवेलेंट डिस्टेंस कितना होता है, इसको करने का एक तरीका होता है कि आप यहाँ से, जैसे सपोज यहाँ से, जैसे हमने यहाँ दिखाया कि ये एक तो ये एक लाइन जा रही है, इसके बीच का डिस्टेंस हमने स्केल से नाप लिया। सपोज हमारा यहाँ पर आ गया 5 सेंटीमीटर, ठीक है। एक तरीका इसको कन्वर्ट करने का है कि ये मैप का डिस्टेंस ग्राउंड में कितने के बराबर है, आप 5 सेंटीमीटर को 50,000 से मल्टीप्लाई करोगे, ठीक है। सो आपका कितना आ जाएगा, 2,50,000। सो 1 सेंटीमीटर, this 5 centimeter on the map is equivalent to 2,50,000 centimeter on the ground. ये एक तरीका इसको करने का है। दूसरा तरीका एक होता है कि आप इसको एग्जैक्टली नहीं एस्टिमेट करें, क्विक एस्टिमेशन निकाल लें। एक अप्रोक्सीमेट वैल्यू जल्दी से आप डाल रहे हैं, उससे निकाल रहे हैं ये कितना आ रहा है। उसको करने की बजाय हम क्या करेंगे, इन दोनों के बीच में, पॉइंट्स के बीच में स्केल रखा। उस स्केल को रखने के बाद में हमने नाप लिया कि स्केल पर मार्क कर लिया कि इतना डिस्टेंस है, या कुछ भी आपने ले लिया, धागा ले लिया, उससे ये लंबाई जो है उसको नाप ली, या एक जो प्रोटेक्टर आता है उसको रख करके नाप लिया, कुछ भी रख करके आपने ये एक डिस्टेंस, या अपना सिंपली हाथ से देख लिया कि ये मेरी 4 फिंगर्स के बराबर, 4 उंगलियों के बराबर ये डिस्टेंस आ रहा है। अब हम क्या करेंगे, उन 4 उंगलियों को ले जा करके इस स्केल के ऊपर रख देंगे। ये आपको दिखाना ऐसे पॉसिबल नहीं है, तो हम इसको इसी लाइन को दिखा दे रहे हैं। ये देखें, यहाँ पर हमने इस लाइन को उठा करके इसके ऊपर रख दिया, ठीक है। तो ये रेड कलर की लाइन आप देख सकते हैं यहाँ पर है। तो एक आप इसमें एक अप्रोक्सीमेशन दे सकते हैं कि ये करीब करीब 2.25 किलोमीटर के बराबर का ये डिस्टेंस होगा। इस तरीके से इस ग्राफिकल स्केल को रीड करना है आपको। अगर डिस्टेंस ज्यादा है तो इधर की ओर ले जाएं। सपोज डिस्टेंस ये कम होता है ना, ये इतना ना हो करके ये इतना होता है। अब ये छोटा डिस्टेंस है तो आप क्या करोगे, इसको लेफ्ट हैंड साइड ले जाओ। तो आप इसको देख करके बता सकते हो, इट इज अप्रोक्सीमेटली 450 सेंटीमीटर। So this is how you can estimate the ground distance quickly with the help of a graphical bar. You have 3 options: ratio scale, verbal scale, and graphical scale. So whichever map you are using, like this one is a very new map. If you go to an old map, this here also this map is in 1977 map. Okay. Again, you can find the same thing over here. The ratio scale, the verbal scale, the graphical scale, all the scales are mentioned over here. Okay. So I hope so the scale thing is clear to you. What is the scale? What is large scale, small scale? What will be the area coverage? What will be the level of detail? Okay. This is another example of the same thing. Okay, this one is from the book, Jan Haywood. You can see the different scale map. All the maps are of London city, and their scale is, first map is at the scale of 6 lakh, 1:6,25,000. Second map is of 1:250,000. You can see how the level of detail is changing. Okay, in the first map, there is the London is shown just by a point. Okay, and as you move at 1:50,000, even you can see this river, the width of the road, and other things. Further, at 1:25,000, more detail, the block level details are coming. Further, at 1:50,000, more details. So as the scale is increasing, as we are moving towards the large scale map, you will find more and more detail is covered. And the area covered is much less. Level of detail is more, but the area coverage is less. So this is all about the map scale. Now we are moving to the next topic. We have seen two topics in map. First was the purpose, second was the scale. Now I am coming to the third topic in the map, and this topic is about the spatial entities. Okay. What is a spatial entity? There are three basic spatial entities in GIS: point, line, and polygon. And even in the map also, you will find that everything, whatever is present in the real world, it will be represented either as a point or as a line or as a polygon. Okay. So these three things are called spatial entities. If you see the more advanced thing, point, line, polygon, and then that instead of line, they are using another thing. The fourth one is network, and another form of area or polygon is surface. Okay. So there are five entities: point, line, polygon, network, and surface. But we focus on first three: point, line, and area or polygon. What will be the spatial entity to represent any of the object? It depends upon the scale of the map. So if the scale of the map is large, in that case, same thing will be represented by a polygon. If the scale of a map is small, then that thing will be represented like a point. So this one is the challenge for a cartographer, how the cartographer is going to represent the object by a point or a polygon, by a line or a polygon. But there are the things like it depends upon the scale, and it's not just only about the scale, it's about the purpose also. Okay. Many times, although we are theoretically saying that the map is constant in the scale is constant over the map, but in the next topic, which is about the generalization, we will find that for the readability of the map, to improve the understanding of the map, the cartographer used to change the things, like important things are drawn with more area or more width. Okay, the stroke is more in that case. First is point spatial entity. So point are used to represent features that are too small to be represented as area at the scale of mapping. Examples are post box, tree, lamp post. The data stored for a post box will include geographic coordinate and details of what the feature is. Latitude and longitude or coordinate reference should be given together with the details that explain what this is. A post box is in current use. Features that are represented by points are not fully described by a two-dimensional geographical reference. There is always a height component since the post box is located at some height above sea level. If three dimensions are used to represent GIS application, this may also be recorded, usually by adding a z value representing height to give an XYZ coordinate. So these are the different things: point, tree, lamppost, which are given over here. Now let's come to the map. I'm opening this 63G map. On the screen, you can find that there are some of the points. Okay, like there are circles, or there are some of the symbol like this, religious places. Okay. So what is this? This is a location, just only a location. It is not going to cover an area, but the things will be represented by a point. Okay. So as you can see in the legend section, the hertz are represented by a point. You can see the second entry in the legend. Hertz will be represented by a point. These temple, chhatri, church, mosque, all these religious places are represented by a point. Lighthouse, light ship. These are the different lightning things. They are represented by the point. Then different type of trees, like they are saying vine, grass, shrub, palm tree, different type of symbols are used, but each thing is represented by a point. Okay, so when we are saying anything location point, it means that it will carry only a location. In the laboratory session also, you have done the digitization of the point, and in the point category you have taken all these things, hut, tree, religious places as a point. So whenever we mark any point, okay, I'm just increasing the size. On the screen you can see that there are points over here. Okay. So when we mark any of the point, you will see yes, when I am double clicking on this one, it is showing. As you can see, when I am clicking on this particular point, I am getting the coordinate, the XY coordinate of this point. This is the X value 58701045031149. So this is the sketch property. The X and Y is coming. And if I want to see the attribute will be listed over here. Okay. The object ID, IT, name, all the details are coming over here for the point. Similarly, for this one also, when I am clicking on this particular point, you can see the latitude X, latitude, longitude values is coming over here, 81 degree or 81.773. This is the longitude and it is coming as an X. 25.421. This is the Y value of this particular point. So this is how the point will appear. I will show you one more data on this one. So one of the student has created the point of all the schools over here. Okay, right now on the screen you can find that these all are the location of primary schools of Allahabad. Okay, so whenever I click on any of the point, okay, so if I click on any of the point, its coordinate will come like 82.020 degree east longitude and 25.512. This one is the latitude. And if I want to see its coordinate, all the information, school code, school name, Sri Krishna Inter College, latitude is this, longitude is this, block name is Phulpur, village is this, number of male teacher 6, number of female teacher is 0, total number of teacher is 6, total number of boys student 211, girls student 212, total number of student 423. This detailed information is present with this one. Okay, so how the data is coming? The data is captured in the form of a point, as you can see on the screen. Okay, and we'll just uncheck everything. So all the schools are coming on the screen. These schools of Prayagraj, they will have to be represented by a point, because you cannot show the school by a polygon because the area is very small. Okay, so it is captured as a point by using the GPS. Every school will have a latitude, longitude value, it has a position value, and whatever attribute has been entered. Okay. So I hope this point concept will be clear to you. I'm coming to the next. This is the line. What is line? No. In a simple geometry, when we say line, it means that it is something that have one pair of coordinate for the starting position and one pair of a coordinate for the end position. So in general way, when we say a line, it means it is a straight line. But when we say a line in GIS, it means a polyline. Okay. So let's read it out. Line are used to represent features that are linear in nature. For example, roads, power lines, or rivers. It can be difficult for a GIS user to represent when a feature should be represented by a line. Should a road be represented by a single line along its center, or by two lines required, one for each side of the road? A line is simply an ordered pair of points. It is a string of XY coordinates joined together in order. This thing is necessary to remember, that when we talk about a point, it means that it is an ordered set of points, or it is an ordered set of coordinates. Why? Because there is a fixed sequence in which the first point will come, then the second point, then the third point, and so on. So it is a string of XY coordinates joined together in order and usually connected with straight lines. Lines may be isolated, just such as geological fault lines, or they may be connected so that they will form a network like road network, pipeline network, or a river network. Networks are sometimes regarded as a separate data type, but really an extension of the line type. Like points, lines are in reality three-dimensional. For instance, hydrogeologists may be interested in underground as well as surface drainage. Adding a z coordinate to the points making up the line representing a stream allows an accurate 3D representation of the feature. Anything can be represented by a line, a road, a river, or a power line. Now coming back to the maps. In the maps, you have done the digitization. Just read these symbols and try to find out which are roads over here. You can consider them one by one. There are so many symbols and sometimes there is a confusion. First is express highway. It will be represented by a line. Road, different category of roads, all will be represented by a line. Canals by a line. Dam probably by a line. River. As you can see the change in the symbol. Okay. So the symbol for the river, and if you see on the map also you will find that river will be in a polygon. Submerged rocks shows probably by a polygon. Well, it will be represented by a point. Then railway. Yes, you can see all these different type of railway, broad gauge, other gauge. All these will be represented by a line. Okay. Now you can see this thing on the map also. This black color line, I think so. This one is for power line. This black color line is the power line, okay, the line with a small circles over it. This one is for the power line. Another thing is road, okay. Then you can see this northern railway main line, okay, electrified. This one will also be represented by a line. So whenever we have a line, so these all are the lines. And suppose, okay, and if I click on this road, you can see how many points are used to make this line. Yes, anyone?
20 points.
19.
20 points.
19.
20.
20 coordinates are used over here because the numbering is starting from 0. Okay. So from 0 to 19, you can see a small road, a very small size road is digitized by using 20 points. Okay. And how this road is drawn? Point 0. Okay. You can see the 0 and 1 have been selected. You can check see the change. When I am checking on 0 and 1, they are automatically get the change in the color. So 0 and 1 will get joined. Okay. And then 1 and 2 will be joined together. Then 2 and 3 will be joined together. This is what I was saying earlier, that line is an ordered pair of coordinate. And in this one also you can find that there is a certain order over here. Okay. This is how the line is drawn by using an ordered pair of coordinates, and minimum 2 points are required. So basically what we are creating polyline over here. But in general, instead of saying a polyline, what we are using a term line. Okay. Another example is I'm showing you another example of Nyc Census Block. Yes. So these are the NYC New York City streets. Here also you can find that suppose if I am clicking on any of the line on any of the road, so you can see that it is getting selected. You can find the coordinate like this line. This is a very small street. So it is created by using 6 lines. And if I click on the details, you can find the detail corresponding to this point, the attributes of this line. The ID of this street is 215. The name of this road is Flatbush Avenue and the type is residential. Okay, this road is a residential road. So there are so many roads over here. Okay, so if you see that these all are the lines. So lines are created. Okay. Lines are created by using a set of points, like this line is created by using 123 points. This line. Okay. So 123 points are used to digitize this line. All the points are arranged in a particular order. You cannot place the coordinate randomly because it is an ordered pair of coordinate. And along this one is the attribute data with the line. And apart from the, this one is the spatial data associated with the line. And this one is the attribute data telling us about the name of the road, about the type of the road. Okay. So this is about the line. Next one is the area or polygon. Okay. So areas are represented by closed set of lines and are used to define features such as field, buildings, or lakes. Area entities are often referred as polygons. Two types of polygons can be identified: island polygon and adjacent polygon. So what is island polygon? As the name suggests that it is island, means if you see the surrounding, it will be completely different. So if there is any water body, which is, or there is some lake inside any city, then that lake will be an island polygon because that lake will be surrounded by the urban settlement. What is adjacent polygon? Adjacent polygon means those polygons that share the boundary. I'm just reading it out. Island polygon occur in a variety of situations, not just in the case of real island. For example, a woodland area may appear as an island within a field or an industrial estate as an island within the boundary of an urban area. A special type of island polygon, often referred to as a nested polygon, is created by contour lines. If you imagine a small conical hill represented by contour lines, this will be represented in polygon form as a set of concentric circles. Adjacent polygons are more common. Their boundaries are shared between adjacent area. Examples include field, postcode areas, property boundaries. Three-dimensional area is called surface. Surface can be used to represent topographical or non-topographical variables such as pollution, pollutant level, or population densities. Some authors consider surface to be a separate fifth type of entity. So these are the different entities that can be represented by a polygon. There can be some field, some building, some lake. It depends upon the scale on the basis of which the polygon will be used. If I come back to the so this is the G15 map. On this map, you can find that there are some polygons that you can draw. Okay. Like there is an urban settlement over here, there is a river over here. All these will be represented by a polygon. Just like a line, the polygon will also be represented by a ordered pair of coordinate, and first and the last point will be the same. Okay. This is not going to happen in the line. First and the last point will not be same, but in the polygon, the first and the last point are same. During the digitization in the laboratory session, you have seen that automatically in QGIS or I am right now, I have opened ArcGIS. So in both of the software, if you are digitizing the polygon, the first and the last point are automatically joined. Okay. Now how the polygon will appear? Let me show you that thing. As you can see on the screen, this one is the map of Allahabad, and this map is showing you the village boundary. Okay, this one is the complete map of Allahabad. And as you can see, a complete digitization has been done for all the villages. So if I same thing I am showing you again. So if I click on any of the polygon, okay, if I click on any of the polygon, you can find the complete attribute, like village code is this, village name is Jirat. I will take some easier one. Okay, this one is the Allahabad city area. So name is Allahabad. The ward number is this. State ID of Uttar Pradesh is 9. District ID means Allahabad district or Prayagraj district ID is 175. Then all the information, total number of population, male, female, scheduled, caste and work, marginal labor, agricultural labors, all the information is added over here. Okay. So you can you can try to imagine what is the meaning of digitization. Okay. यहाँ पर आप जैसे देख रहे हो, यहाँ पर सारे villages किस level का digitization यहाँ पर किया गया है. यहाँ पर total इस डेटा को हम लोग चेक करें अगर 3077 यहाँ पर एट्रीब्यूट्स हैं, यानी कि 3077 विलेजेस इसमें पूरा डिजिटाइज किया गया है. okay? और डिजिटाइजेशन के लिए जैसे लाइन में किया गया था बिल्कुल वैसे ही पॉलीगन में भी होता है. यहाँ पे भी अगर आप देखेंगे तो यहाँ पर इस पर्टिकुलर ये ग्रीन कलर से आप जो स्क्रीन पे देख रहे हो एक विलेज है और इसका डिजिटाइजेशन किया गया है और इसको डिजिटाइजेशन करने में 105 पॉइंट्स का यूज किया गया है. तो यहाँ पर देखिए पहले का नोट डाउन करिए. पहला पॉइंट का कोऑर्डिनेट XY कोऑर्डिनेट लॉन्गिट्यूड लैटिट्यूड यहाँ पर लिखा हुआ है 81.952 एंड 25.337. ओके, यहाँ पर आखिरी पॉइंट देखिए 104 पॉइंट. ये लास्ट पॉइंट हमने चेक किया है और ये 0 मीन्स फर्स्ट पॉइंट एंड द लास्ट पॉइंट. ये देखिए तो ये दोनों पॉइंट जब यहाँ पर चेक किया गया है, यहाँ पर आप देखते हैं कि ऑटोमेटिकली लास्ट पॉइंट पहले पॉइंट से जाकर के ज्वाइन हो जा रहा है. तो सेम डेफिनेशन एज ऑफ द लाइन. पॉलीगन क्या है? ये एक ऑर्डर्ड पेयर ऑफ कोऑर्डिनेट होता है जिसमें कि फर्स्ट कोऑर्डिनेट एंड लास्ट कोऑर्डिनेट ऑटोमेटिकली ज्वाइंट होते हैं और इसी के साथ में हम एक पूरा एट्रीब्यूट इसके साथ में ये एसोसिएट करते हैं.
Ma'am,
यही का. यस
ma'am, if someone wants to access this information, then that person has to use this software only, then only he can access the information. Otherwise,
means how do you want to access the information?
ma'am, suppose
Just-
government wants information.
Okay, so you want to see this information. In that case, we have the web GIS. In the next semester, you will learn about the web GIS. Right now, whatever you are doing in your own personal computer. सारा डिटेल जो है वो आपके अपने सिस्टम पे है, आपके अपने सॉफ्टवेयर के हेल्प से आप उसे एक्सेस कर रहे हो। जैसे QGIS है, अभी आज के सेशन में हमने सारा GIS आपको दिखाया। सपोज हम इसी काम को चाहते हैं कि कोई हमने कोई डेटा यहाँ पर बनाया और उसको कहीं पे कोई भी व्यक्ति उस डेटा सेट को देख ले। उस केस में हमें क्या करना पड़ता है, वी नीड टू अपलोड ऑल दिस डेटा ओवर दिस सर्वर। वहां पर वेब GIS का एप्लीकेशन आता है। उस केस में जो क्लाइंट मतलब जो यूजर है उसको कोई जरूरत नहीं है कि इस तरीके के किसी GIS बेस्ड सॉफ्टवेयर को यूज करे। वहां पर अपने आप वो ब्राउजर के ऊपर जैसे आप बाकी वेबसाइट्स को देखते हैं उसी तरीके से इस तरीके के स्पेशल डेटा को भी आप देख सकते हैं। एक क्योंकि आपने क्वेश्चन पूछा इसलिए जल्दी से इसको एक बार हम दिखा दे रहे हैं जो आपने पूछा है। एक यहाँ पर क्योंकि मेरे सिस्टम में ऑलरेडी है तो यहाँ पर हमारे पास में अपाचे टॉमकैट वेब सर्वर है और जियो सर्वर के नाम से एक GIS सर्वर है। यहाँ पर हम सर्वर को स्टार्ट कर रहे हैं, थोड़ा टाइम लगेगा इसमें। Now server is started. I will do. I am typing localhost:8080/GeoServer. ये सारा चीजें कैसे होता है आप अगले सेमेस्टर में लर्न करोगे, लेकिन यहाँ इतना देख लीजिए कि ये एक हमने आप यहाँ देख रहे हैं कि हमने वेब ब्राउजर, हमने कोई सॉफ्टवेयर नहीं खोला, हमने अपने वेब ब्राउजर पर इस पर्टिकुलर जियो सर्वर को खोला है। जो स्कूल का डेटा अभी हमने आपको ArcGIS पे दिखाया था, है ना, वही सेम डेटा स्कूल का पॉइंट डेटा अभी आप यहाँ पर सर्वर पे देख रहे हो। क्योंकि ये मतलब इसको अभी कहीं पर डाला नहीं गया, लेकिन इसी को डायरेक्टली आप कहीं पे भी एक्सेस कर सकते हो। हम किसी भी पॉइंट पर क्लिक करेंगे, आप यहाँ देख रहे हैं कि यहाँ पर लोअर लेफ्ट कॉर्नर पे, लोअर राइट कॉर्नर पे उसके कोऑर्डिनेट्स आ रहे हैं। हम किसी के ऊपर भी अगर क्लिक कर रहे हैं, ठीक है, एक स्कूल के ऊपर हमने क्लिक किया, ऑटोमेटिकली उसका जो डिटेल था, ये देखिए इस स्कूल का पूरा डिटेल यहाँ पर नीचे लिस्ट हो गया है। तो इस तरीके से कोई भी व्यक्ति, मतलब इट्स नॉट नेसेसरी कि आप GIS प्रोफेशनल है और आपको GIS सॉफ्टवेयर आता है तभी आप इसको व्यू कर सकते हैं। इसके लिए आप सर्वर पे अपने डेटा को अपलोड करके ये सारी चीजें डिजाइन कर सकते हैं कि एनीबॉडी जिसके पास में इंटरनेट कनेक्शन है, एक वेब ब्राउजर है, वो इन सारी चीजों को एक्सेस कर सकते हैं। ठीक है, तो आज के लिए इतना ही। एक चीज इसमें आपको और ध्यान से फिर से रिपीट कर रहे हैं कि ये विलेज का डिजिटाइजेशन आप लोग थोड़ा देखिए, क्योंकि आप लोग ऑलरेडी डिजिटाइजेशन की प्रोसेस कर रहे हैं और क्योंकि जो टोपोग्राफिक मैप्स हैं वो सारे इलाहाबाद के आप यूज कर रहे हैं, तो आप यहाँ पर ये देखिए किस तरीके से डिजिटाइजेशन किया जाता है। ठीक है, अभी तो आप लोग बहुत छोटा डिजिटाइजेशन कर रहे हैं और ट्यूटोरियल सेशन में आगे चल करके अभी आप लोग को सारे इलाहाबाद के मैप्स दिए हुए हैं, ऑल टोपोग्राफिकल मैप्स ऑफ प्रयागराज। तो वहां पर भी आपसे अभी इसी तरीके से एक्सट्रैक्शन करवाया जाएगा कि इसमें आप जाकर के डिस्ट्रिक्ट बाउंड्री एक्सट्रैक्ट करिए, फिर तहसील बाउंड्री एक्सट्रैक्ट करिए, ब्लॉक बाउंड्री एक्सट्रैक्ट करिए। ये तो विलेज बाउंड्री है तो बहुत ज़्यादा डिटेल्ड है, बट आप इस तरीके से एक्सट्रैक्शन करना सीखेंगे तो वहां पर आप देखेंगे कि इस तरीके से आप पॉलीगन्स को बनाते हुए वहां पर अलग अलग चीज़ों को, अलग अलग तहसील, ब्लॉक, डिस्ट्रिक्ट, इन सबको एक्सट्रैक्ट। So that's it from my side for today. आपके एंड से कोई क्वेश्चन हो तो पूछिए। Any question from your side? Okay then, thank you so much. The class is over for now.
Thank you.
Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.